we have our next talk that is about to start. It will be given by Vladimir Dashchenko. Unfortunately, his partner Sergey could not be here, so he's going to be handling this one solo. And it's going to be on Pwning, the industrial IoT, RCEs, and backdoors are around.
All right, thank you. Hello, everyone. Thank you for joining our session with Sergey. He's supposed to be standing right here next to me, but unfortunately, he cannot come here due to a super long process of getting visa to United States. But anyway, Sergey, hi. And today, me and Sergey, we're going to talk about the different vulnerabilities that we have identified for the last, I guess, 15 months. In different industrial devices, but we will be focusing on the industrial Internet of Things. So I will give a brief explanation what is the industrial Internet of Things, what we have identified. But first, I would like to mention that me and Sergey, we are working at the non-profit project in Kaspersky Lab. It's called Kaspersky Lab ICSR, and basically what we do different vulnerability research, we do different sophisticated malware analysis, we're tracking different sophisticated attacks on the industrial components and stuff like that. So we are a group of people who has different and super cool background in malware analysis, penetration testing, security audits, security analysis, and blah, blah, blah. All right. So what is the industrial Internet of Things? So you guys probably know that there are normal general Internet of Things right behind you, right? So this is a new type of the concept, general Internet of Things, new type of the concept when different vendors are trying to make any product smart. Smart this, smart that, everything is smart, people are smart, things are smart. But industrial world is also trying to go towards that way. So you probably can hear about or heard about the different smart meters, smart devices and stuff like that. It helps to industrial companies to lower the expenses on different things. For example, smart meters are trying to help to track how much electricity are we using, and maybe we can reduce the usage of electricity somewhere. Anyway, so this concept means that everything is connected. The smart industrial devices are also connected, right? And they are connected with the operators level. So all the information, all the metadata is going to the operators level. So the human can process that and can see what's going on with the data. Basically, what is industrial IoT? Yeah, it's a fancy and cool concept, right? And it's a fancy and cool solution, but still, it has the old security problems. If we will take a look, if we will see the low-hanging fruits in the vulnerabilities, even in new solutions in industrial control systems and industrial IoT stuff, we will see that there are also still hard-coded passwords, I don't know, super stupid cross-site scripting vulnerabilities and stuff like that. But there is something bigger. This is the basic statistics that we have identified. So how many vulnerabilities and types of the vulnerabilities we have found. As you can see, the major part is goes to the denial of service vulnerabilities. But the thing is that in industrial world, DOS vulnerabilities can be way more dangerous than remote code executions. So if there is a technological process and the attacker is trying to exploit the denial of service vulnerability, that vulnerability, that exploitation can stop the whole technological process. So they will start using the money, losing the money, or something more dangerous can happen. We also found several injections, file manipulations, and there is one vulnerability right here, the account manipulations. It's basically, it's not a bug, it's a feature, I was told by the vendor. So the thing is that the remote attacker can disable legitimate user for like 2 or 3 hours, so the user will be blocked totally. So we submitted that vulnerability to the vendor, and the vendor was like, hey, you know what, it's not a bug, it's a feature. You can increase the time like in the configuration file. I was like, well, okay, it's not going to take like 2 hours, not 2 hours, but 3 hours. And they were like, we can just input this thing in our FAQ document, so they can just increase the time till 10 hours. I was like, well, it doesn't make any sense. So there is no CVE for that type of vulnerability, but, well, looks funny. Anyway, so basic vulnerability research approach. First we start researching the custom-made protocols. It's super cool and it's super interesting to go deeper into the like custom-made protocols. Then we start playing with DCOM protocol. And then we were playing with OPC UA. Did anyone heard about the OPC UA? Cool, interesting. That's awesome. So OPC UA, it's a concept. It's open source type of the protocol and the way of communications of the devices. So yeah, the source code is available, and basically this is like a Lego for industrial companies. So using those tiny bricks of the OPC, any company, any vendor can build like a huge system on that. And the new approach is the common solutions. So we have identified that there are lots and lots of different common solutions among the hundreds of different vendors. So here are the examples. The first thing is about the custom implementation of the excuse me, about the custom implementation of the XML. So we have identified that if you're inputting the random data without knowing any tags, the server side returns you the basically what are the tags and what are the fields should be, the legitimate fields. We were like, okay, that looks interesting. So basically, if you input like XXX, the XXX thing, it starts, comparing if there is a field naming XXX with the real ones. And he's like, this thing is going through the whole thing and shows like, if XXX is equal to AC, EC computer object and blah, blah, blah. Then we enhanced that thing, and we have found that there are different. So we basically have built the whole tree of the XML. That looks great, and that basically gave us the remote code execution. But it wasn't the binary remote code execution; it was the logical remote code execution, which looks better than the binary one. The second example is about the OPC custom implementation. So this is basically the whole proof of concept of the denial of service. We have internal feeling that there is a remote code execution behind that, but we still haven't found the way how to exploit the remote code execution. So yeah, this is the example how how we have identified that, and you just need to send a tiny packet to exploit the vulnerability, and that's it. The system goes down. And my favorite example. So if you remember how my presentation, yeah, let me just show the name of the presentation right here, right? So you see, there are remote code executions and this word. This vendor didn't want me to name that word, so I decided to change that word into the other one. You will see now. So yeah, custom protocol, but first custom protocol. So first we have identified this thing just in like ICS and industrial IoT things, but it became huge, like super huge. So there is a custom-made protocol. So if you interact with that protocol as with the HTTP server, it will work with you as like HTTP server. If you input binary data, it allows you to do like some binary things with that. So what happened? These guys, they had a custom-made, packer for their solution. So they wanted to protect their solution from like researching and stuff like that. But for some reason, they have removed well-known security things. For example, canary stack, like safe cookie and stuff like that. Basically, what does it mean? If you find like the point where this thing crashes, you can just go, like you can just exploit the remote code execution like super good. So if you, I don't know. If you pay attention, you will see that there is like AAA, and so it goes like really good and fast, so it allows you to do the remote code executions. But after we have submitted the vulnerability to this vendor, strange things started happening. We submitted the vulnerability in December 5th, 2016, right? So we submitted them 2 different remote code executions and 11 denial of service. Then I sent one more reminder because I didn't get any feedback from them. Then I sent one more reminder and one more reminder. And in January of 2017, I got the feedback from them that they received our vulnerability report and stuff like that. Then I was sending them reports almost every month, but nothing happened. So they were just sending me back like, hey, just yeah, thanks for your email. You just have to wait for our feedback. Then they in when was it? May or June? They have submitted a new version of the driver, but they didn't make any announcement. After I didn't know that, and our team didn't know that, and we're still sending them emails, and they were still replying that, hey, we're still working on that problem, but the driver was updated. It turns out that even after the driver was updated, they didn't submit the new version of the driver to the like Microsoft. So if you update your Windows system, it will not get the new version of the driver. That looks strange. After we decided to do this DEF CON talk on this vulnerability, I have sent them email saying that, hey guys, we're gonna do like IoT Village talk on the DEF CON about this vulnerability, and they were like, oh, hold on a second, we got actually the advisory published, but the advisory is on the like private website, so you cannot like get it like online, so you have to get the you have to log in somewhere, get the advisory and stuff like that. They didn't want to submit any CVEs, so we did that for them. Yeah, we of course notified the US ICS cert on this vulnerability, because the thing is that first we thought that this vulnerability is only like in a like super custom-made solution, and we didn't pay any attention. But then we start like looking deeper and wider, and we have identified that it's super huge. Yeah, so those CVEs are ready. It turns out that these guys, they work with the thousands and thousands vendors under the OEM, under the OEM thing. And basically each vendor has thousands of the clients, right? So we still don't know how many people and how many companies are still vulnerable. And we don't know how to notify everyone. We didn't know how to notify everyone to update the driver. So this strange things started happening. We continued our research on that, And we have identified several strange functions, some functionality. Okay, so basically, what if you can remotely turn on and turn off the administrative panel using undocumented API functions? What if you can remotely make a configurations on the do the changes in the configuration file using the legitimate API functions again? And it will not be so the security administrator will not see that, right? How do you call that? What's the name for that? I'm not allowed to say that word, but anyway. So it turns out that those guys were doing some stuff someday, I have no idea when. So when we reported this functionality, undocumented functionality to them, they were like, no, it's not a bear, it's not that thing. It's our mistake in the code. And we were like, hey, you just have a hidden functionality like in your solution, right? But like, how can we manage that? So how you cannot agree with this word? And they were like, no, we don't agree with this word. So we decided to call like not a bear thing. This is basically what I have just said, like remotely enable and disable administrative panel. It's non-documented. And the panel is available by default on like the local host, right? And the other thing is that basically if you have a Windows-based computer, right? And the computer is locked, right? So you can just take this thing, this USB device, like it's official thing from the vendor, like it's not fake. You just plug in this thing, right? What happens next? The driver, the vulnerable version of the driver is being uploaded from the Microsoft servers, right? This thing opens a port. The port is being added to the legitimate and open port to the Windows firewall, and the Windows firewall allows that port open, and that's it. That's done. Basically, right? You have the vulnerable Windows machine with open port and with some strange functionality. So we started researching that thing, and so the manipulations with the configuration file. So basically, you can change the proxy server for the binary updates. So if the attacker changed the proxy server for the binary updates, so you know what's going to happen. And we also have identified that it is possible to capture the NTLM hash of the built-in user of there are several built-in users in the Windows operation system, so you can capture that NTLM hash function, and that's it. So we submitted the thing to the vendor, and they were like, hey, you cannot do the SMB relay attack. I was like, yeah, of course we cannot do, because it's a built-in user, so it's not possible, but still there is a possibility to do that. So we decided to, we agreed with the vendor to publish this advisory. So, but the thing is that we don't want to leave the world vulnerable. We decided to provide open source and free OVAL definitions, so they are available and you can download them, and you can use the Mitre tool to play with those OVAL definitions, and you can check if your system vulnerable or not vulnerable to that thing. The alert is available here under this link. And so what are the conclusions? So if the best thing is which can help to protect this world is knowledge sharing. If you share the knowledge, everyone will be protected. The second thing is, well, if you made a mistake someday, you have to admit it. You have to admit that, well, there was a problem, but we're doing our best to fix the vulnerabilities. And of course, if you are going towards the new concepts, for example, Industry 4.0 or industrial Internet of Things or blah, 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 whatever, Well, you have to do it right. You have to put the security on the basement. Everything should be secured by design, not like, those things. And of course, if there are different third-party solutions are used in a huge like industrial or industrial systems or industrial Internet of Things, you have to test them properly. So if you are like if there are any vendors and if you are using the different third-party solutions, you have to test them first. You have to see like the source code, or you have to do the vulnerability research of that. So you have to work. You have to do what you have to do. Okay, I guess that's it. Thank you. Whew. Yeah. So if you have any questions, I'll be happy to answer. Yeah, yeah. Oh, it's different. It's different. Our research group is working on the. So we're CERT, we're like a computer emergency response team. So what do? We do the like vulnerability research, incident response. If the customer asks us to do the penetration testing, we do that. So it's like we're research department, the research group of people. Okay. Thank you. Yes. I can't hear. Yeah. Let me show you. So yeah, you're talking about like this case. Yeah. So basically, they have turned off, not turned off, but they didn't use, for example, safe cookie. There is a special mechanism. It's called like safe cookie, and they didn't use that like when they were writing the code for that binary, and like they didn't use like a really common and world-known security mechanisms. Yep. All right.